Okay, so we're now going to apply all these together. So, example 4 says find all the variables. So if we look at this first example, first thing that we need to know is that we're given that AB is equal to BC, and that's going to be really important. So I'm going to mark AB congruent to BC, because here's what we know from that. This is from our last section in 10.3, is we know that this arc has to be congruent to this arc, okay? All right, so here's where I would start. I would look at the fact that I have this inscribed angle, and it's matching up, intersecting this arc right here. So what I know is that this arc of AC is going to be double that of the 30 degrees, so it's going to be 60 degrees. Okay, so now I need to find X and Y though, all right? But what I'm going to do in order to find Y first is, because these are congruent, I'm going to do 360 minus 60. And then I'm going to divide that by 2. So I'm going to divide that 300 by 2, which means that both of these arcs, because they're congruent, are 150 degrees. Okay, so I found my Y. All right, so my Y is 150. But now I'm going to go ahead and erase this highlighter. And I'm now going to look at the fact that this angle C, all right, the one that has the X in it, is inscribed to this 150. So what we know is that this angle right here has to be half of the 150. So I know that X has to be 75. So my X value was 75, and my Y value was 150. Let's try the next one, okay? So looking at this next one, we need to find X, Y, W, and Z, okay? And here's what I would notice right away. I have this semicircle right here, and I have an angle that's inscribed in that semicircle. So what I know is that angle X has to be 90 degrees. That has to be a right angle. So I know X is 90. The next thing I'm going to look at now is I'm going to look at this 25. So if I look at this 25, I'm going to notice that it's an inscribed angle, and it's inscribed to this arc right here. All right. And so if that angle is 25, we know that the arc has to be double that angle. So I know that W is equal to 50. And obviously, guys, this isn't drawn to scale, all right? Because if W is equal to 50, Z is the other portion of that semicircle. So that means that W plus Z has to equal 180. And so that means Z is equal to 130. But now, if I look at the angle that's inscribed to Z, that's going to be the Y, which is going to be half of that Z. So Y is going to be 65. All right, our last two are applications of our last theorem, which is that the opposite angles in an inscribed quadrilateral are supplementary. So if you look at X here, that's opposite of the 110. So really quickly, X is going to be equal to 70 degrees. And same idea, all right, for Y, it's across from the 85. So if I subtract that 85 from 180, I get 95. So my Y is 95. A common mistake is that students like to make them congruent, all right, and they're not congruent, all right, because it's not a parallelogram. Okay, so our last example is, again, just like this. So I'm going to look at my 2x and my 58, and I'm going to add them up, set them equal to 180. So I'm going to do 2x plus 58 is equal to 180. Solving for x, I got x is equal to 61. All right, same idea with the y's. I'm going to take the 2y plus 16, add that to the 3y plus 4 and set it equal to 180. Simplifying, I'm going to get 5y plus 20 is equal to 180. I'm going to subtract out that 20, so 5y is equal to 160. So dividing that out, I get 32. So my y is equal to 32. Okay? All right, so this was a very dense set of notes, lots of new theorems and lots of different applications, okay? So let me know if you have questions. We'll be practicing this tomorrow. Have a great night.